Welcome to the Fluke 3540 FC 3-phase power monitoring training. This training will provide an overview of the Fluke 3540 FC system and explain how it is used to monitor electrical system performance. We will also review the basic components of the monitoring system and how electrical data is collected and the safety considerations involved when installing and using this equipment. The goal of this training is to understand the purpose and function of the Fluke 3540 FC power monitoring system. We will review how the monitor is used to collect electrical measurements, identify the components used during installation, and explain how the device records and stores monitoring data. We will also discuss important safety considerations when installing and working with monitoring equipment. The Fluke 3540 FC is a portable 3-phase power monitoring device used to evaluate electrical system performance and load conditions. It allows teams to monitor electrical equipment remotely by streaming measurement data to the Fluke Connect cloud. This capability helps identify abnormal electrical conditions and provides valuable information about how electrical systems are operating over time. The monitoring system records several types of electrical measurements. Basic electrical measurements include voltage, current, and frequency. The device also records power measurements such as active power, apparent power, reactive power, and power factor. In addition, the monitor tracks power quality measurements like total harmonic distortion, voltage harmonics, and current harmonics, which can indicate abnormal electrical conditions. Before installing monitoring equipment on any electrical system, proper lockout-tagout procedures must always be followed. Workers must verify the absence of voltage using an approved meter and perform a live-dead-live test when verifying circuits. Proper arc flash and shock protection PPE must be worn when working around electrical equipment. Monitoring devices should only be installed after safe conditions have been verified. The Fluke 3540 FC monitoring system includes several components that work together to collect electrical data. These components include the 3540 FC power monitor unit, voltage test leads for 3-phase measurements, flexible iFlex current probes, a power supply or battery, and a Wi-Fi adapter used for communication with the Fluke Connect system. The iFlex current probes are flexible current sensors used to measure the current flowing through electrical conductors. These probes use Rogowski coil technology and can wrap around live conductors without disconnecting them. Their flexible design allows installation inside tight electrical panels while still providing accurate current measurements for power monitoring. The Fluke 3540 FC can record electrical data using 2 operating modes. In monitor mode, the device streams electrical data in real time to the Fluke Connect cloud so it can be viewed remotely. In logger mode, the device stores measurement data locally on the instrument. That data can later be uploaded and reviewed using the Fluke Connect application. A typical monitoring setup begins by installing the iFlex current probes around each phase conductor. Voltage test leads are then connected to the appropriate phases and neutral. It is important to verify that the arrow on the current probe is pointing toward the load. The monitoring unit is placed outside or near the electrical panel, and proper phase rotation and connections should be confirmed before starting the monitoring process. The front panel of the Fluke 3540 FC includes controls used for navigating and configuring the device. The unit contains input connections for voltage and current measurements, a touchscreen display used to view electrical data, and USB or communication ports used for transferring data. The device can also be powered using an external power supply when necessary. Power monitoring provides several important benefits for electrical systems. It helps identify overloaded circuits, detect abnormal electrical conditions, and improve overall energy efficiency. Monitoring data can also support preventative maintenance programs and help reduce unexpected equipment failures by identifying potential issues early. To wrap up this training, always remember that safety comes first when working with electrical monitoring equipment. Inspect probes, test leads, and monitoring equipment before its use. Wear the proper arc flash and shock protection PPE, and follow all Inglet & Stubbs safety policies when working around electrical systems. Always verify the correct wiring configuration before beginning monitoring, and refer to the manufacturer's documentation if there are any questions about the equipment. Proper storage and handling of monitoring equipment helps ensure it remains safe and reliable for future use. If you have any questions about this training or equipment discussed today, please contact the safety department.